Good morning. Today we're going to talk about our next section, 13.2, which is exponential decay. So 13.1, whoops, sorry about that. 13.1, right? Hope this pencil works. Introduced exponential growth, right? And we saw graphs that grew very quickly. So they did something like this, right? Now, exponential decay is something that decreases very quickly. So it's basically this graph. So let's get moving. All right. It's the same parent graph. Some, number b raised to the x. Remember, exponentials are where the variable is in the exponent. But in this case, b is between 0 and 1. It's always positive, but b is between 0 and 1 for decay. And just to compare, b was greater than 1 when we had exponential growth. Okay? Now we're going to look at a parent graph where b is 1/2. Oh, good thing I got my calculator here. But you're going to find some similarities, a lot of similarities as you move from growth to decay. All right, this is the parent graph. Let's just remind ourselves, right? A is 1, h is 0, k is 0. The domain of any exponential function is always all real numbers, right? That's a nice little gimme, just remember that. Range had to do with k, didn't it? Right? Our asymptote, our horizontal asymptote, was always y equals k. What we're going to find here, and you can graph it and look at it if you want, is that this function, does this. So its range, right, is everything greater than 0. So 0 to infinity. And then, like we said, the asymptote in this case would be y equals 0, right? We have this horizontal asymptote that this graph right here, it approaches, but it never hits. So 12, it's not 12, it's 1/2, just making a point, raised to the x. There is no x you can put there that you can substitute in that makes that 0, right? Sorry, I just had to grab my coffee. All right, so I am going to graph this on my calculator and we're going to look at end behaviors, okay? All right, so it's going to be 1/2 raised to the x. So I'm going to graph this. I'll take this graph out for a second, make it more official. And this is what we're going to find. Here's our parent, right? We're going to have reference points similar to what we had with the growth. And one point we always had was this point right here, which was 0, 1. Then we have a point up here. This is, this is going to be, we'll look at that in a minute. All right, so this graph does this. Okay, so you guys look at it as, if we're talking end behavior, as x approaches infinity, that's this direction. What does f of x approach? Well, we said there's an asymptote here at y equals 0. It'll approach but never hit 0, right? And as x approaches negative infinity, look where this thing's headed, right? F of x approaches infinity, okay? And we just figured out the y-intercept on this parent graph is 0, 1, right? So this, if you look at this, what happens to this graph throughout the whole graph? Is it increasing or decreasing? It's decreasing, right? You read a graph like you read a book from left to right. Okay, let's look at our next one. All right, so here are the reference points we're talking about. We had, for growth, remember, we had some reference points that looked like this, 0, 1, and 1b. Yes, 1b. Now we're going to use reference points 0, 1, always the y-intercept, and negative 1, 1 over b. So let's see how that works. Okay, so keep in mind these reference points. We're going to move here. So our reference points are 0, 1, negative 1, 1 over b. Now if I go back, it's going to say h, a plus k. This is in our transformed, right? We're going to look up our a, b, h, and k. And then, excuse me, h minus 1, a over b plus k. H minus 1. Now, they look a little intimidating, but they're not. We just have to memorize them. And I'm just looking for the dog. There she is. Okay. So, first thing we're going to do, remember, we don't have the b of our transformations. We don't have a horizontal stretch or shrink at this point. So let's look. A equals 3. B, well, yeah, don't need b. The b here is 1/2, so that means this is exponential decay, right? H is 2, k is a negative 2. So let's write our general function up here to help us out. A, b to the x minus h plus k. All right, so it says use the reference points in the asymptote shown for the parent graph. Our asymptote is y equals 0 or y equals k, right? Y equals 0 is the parent. To graph the function. So let's do this. So we can tell from looking at these numbers, our 0, 1 y-intercept is now moving to be h, a, plus k. So it's 2, 1. Okay, and then this reference point, right, will be h minus 1, h is 2, a over b. So a over b. Someone want to tell me what a over b is here? We don't divide fractions, instead we multiply them. So it's 3 over 1 times 2 over 1 is 6. So this would be a over b is 6 plus k. So 1, 4. All right, 2, 1, 1, 4. So it's going to do something like this, isn't it? I'm going to graph it before I put it on the sheet. So this is 3 times 1/2 raised to the x minus 2 minus 2. It's thinking, but there it is. Okay, I'm going to look at my, remember our y equals k, y equals negative 2 is our asymptote, isn't it? This is our asymptote. So this thing actually comes and does this and does that. So these 2 points were good. That's good. Now, let's look at our domain and range. What did we say the domain is? Every single time. All real numbers. We're writing it in interval notation. What did we say the range is in? So notice it's greater than this asymptote, isn't it? And our asymptote's at negative 2. So it's negative 2 to infinity. And it doesn't include negative 2 because it's an asymptote. All right? Let's try the same thing in another problem. Just making some notes for myself here. All right, let's look at another example. All right, so what I'm going to do to help us out is I'm going to write our a, b to the x minus h, not h, but x minus h plus k. Okay, so look at this problem, guys. What is a? A happens to be -1. All right? We don't have to worry about B. The exponential decay part of it, it's 1 over 10. H equals a -2. K equals 8. So what do we automatically know just looking at this is that we have an asymptote, a horizontal asymptote, right? At y equals 8. All right, let's take our reference points. Our first reference point is 0, 1, and it changes to H, A plus K. So let's see what this point is. H is -2. A plus K. So it's going to be -2, -7. Interesting. All right. Then our other reference point will move to, just going to write it down, H minus 1, A over B plus K. All right, so H minus 1, -2 minus 1 is -3. A over B, so -1 over 1/10 plus K. All right, so remember, this multiplied by the reciprocal, so that's a -10 plus 8. So this will be -3, -10 plus 8 is -2. All right, I'm going to graph this on my calculator. Y equals 8. 1, 2, 3, 4, 5, 6, 7, 8. -2, woo, it's 1, 2, 3, 4, 5, 6, 7. -3, -2. So notice our asymptote is above. Remember what a negative A does to the parent graph. This graph is actually reflected over the x-axis. So let's see what that looks like. So I have -0.1 raised to the x plus 2 plus 8. So just if our parent graph does this, the shape of this graph's got to do something like that, right? This would be reflected. In 1/10, this is really steep. Let me see if I did the points right. -1 play. Oh, I'm sorry, you guys, this is 7. I'm sure you guys were yelling at the computer telling me it was 7. -2, 7. So this thing, when you look at it, it's really, whoops, without running over the, that's the shape of the graph. So it is still, it's a decay that's been reflected over the x-axis, right? Similar to what I showed you here. But we follow the same process. Identify A, H, and K. Get your reference points and your asymptote, right? And you'll be able to graph it. Okay, moving on. Now, we did some of these in growth, but we have to remember the same equations that we just used for the reference points because it's going to help us get the equation. It's going to help us figure out H and K, right? So here's what we have. We have this graph, and we got to figure out what K is. And remember, Y equals K is our asymptote, isn't it? Horizontal asymptote. So we know that K equals 4. What else do you notice about this graph that's similar to the one we just did? This is reflected over the x-axis. So our A is going to be negative, isn't it? So we got to watch for that. We're going to sense check. Is our A actually negative? Now we're going to run out of time, guys, so I'm going to stop it and start a new video that'll complete this problem. Okay? Hang in there.